Now that we've added the format validation on email addresses, there's actually only one validation left, which is the uniqueness validation. So let's write a test for that. What we want to do is make sure that there's a duplicate email address in the database, in the test database in this case. So remember, we did user.new here. This does not save the user. So one of the things we'll have to do in this test is to save the user to the test database. So let's do this, and then let's make a duplicate user that has the same values as the current user. Called the duplicate user. And there is a method for doing this called dupe. It just duplicates the values. So we can go in here and say, we can't just say duplicate user equals @user because then they're the same object. What we want to do is make a copy. So that's what dupe does here. And then we want to save the user. Right, if we just did this, when we saved the user, it would actually save the duplicate user too, because they're the same object. So dupe fixes that problem. So then in the test, we want to save the user, and then what do we want to do? We want to say that this duplicate user, which exists only in memory, right? We have not saved this user. We want this duplicate user not to be valid. So assert not this thing valid. So assert not duplicate user. Oops, why didn't that work? Dot valid. So we save this. This should fail, right? Because remember, we want to get to red for test-driven development. And let's get to green. Okay, let's take a look at this here. What we want to do is add the uniqueness validation. Unique true. Save it, and we'll be green. Oops, that didn't work. Oh, uniqueness. Now we'll be green, right? All right. So we're done, right? This is it. We've solved the problem. Yay. Alas, not. There are actually a couple of things that are wrong. So let's look at the first one. Now, technically speaking, two email addresses that differ only in case are in fact different. So this, actually just do this here. So this email address, technically speaking, is different from this. But this causes all kinds of confusion, potentially, and most email systems consider these to be identical. And even if we wanted to consider them to be distinct, so many other systems consider them to be the same that this would cause terrible interoperability problems. So we're going to consider these two to be the same, and let's go back to our guard window. Again, we want to get to red first, so let's get a failing test. Let's take this duplicate user and just upcase its email address. We actually saw upcase in the context of map in lesson 4, but what this does is just upcases the email address. So does this. So this duplicate user now has the same email address except it's all uppercase, and it should still not be valid, but it will be because uniqueness true doesn't have any sort of case insensitivity. So this is red now. So the way to do this is to change this true to a hash, which is case sensitive false. So the hash is the key is case sensitive and the value is false. To turn off case sensitivity, this implicitly has uniqueness true in here, so this should work. Nope, it didn't though. Oh, I just did something stupid. I said duplicate user is equal to this. This is just a string. But what I want to do is assign the duplicate user email address to this. So there we go. This should work now. Great, so let's just go back here. Oops, I'm going to do this here. Get to red, and then go green, just to make sure we're testing the right thing. All right, there we go. So at this point, you think we're definitely done, right? Let's run the whole test suite. So this looks promising, and in fact, it's almost completely done. But there's one scenario that we haven't accounted for, and this is really quite tricky, so let me go through it. So the scenario is when a user, let's call her Alice, accidentally clicks twice in quick succession on the account creation button. Under certain conditions, this can create duplicate users, that is to say users with the same email address, thereby leaving the database in an invalid state. So what happens is the first click goes through and the first user object passes the validation because there is no such user in the database. Then the second click also creates a user variable that passes validation because the first user hasn't yet been saved. Then the first user gets saved, and then the second user gets saved. Because the second user already validated, the second save goes through, and you end up with duplicate email addresses. This actually happened to me on a site several years ago. This is how I learned about how to solve the problem, which is to enforce uniqueness not only with a validation in memory here in this Ruby code, but also at the database level. The way to do that is with what's called a database index. So the idea behind an index is actually not related specifically to uniqueness. It's actually designed to make finds more efficient. So let's go over to the console. And actually, my user somehow disappeared. I'm not sure how that happened, so I'm going to create a new one. User.create. Let's just say name is so that created a user, and now we can do something like this. We saw this before. So this finds the user with this email address. But if you think about it, suppose there were, say, 10,000 users in the database. In order to find by a particular email address, you would, in principle, have to go through every single record in the entire database. In the database business, that's called a full table scan, and it's a potentially very costly operation in terms of computational cycles. So in order to make that fast, ordinarily what you would do is add an index. And the way an index works, it's just the same idea as a book index. So for example, suppose you wanted to find the occurrence of M. Hartle in a book. Now, if you're dealing with an electronic book, you can just search through it. But with a print book, that won't work. And in principle, you would just have to go through every page and try to find where this string occurs. But of course, there's a traditional solution to this problem in the publishing industry, which is to make an index. So you would have an entry at the end of the book, and it would say that M. Hartle appears on, say, page 5, 17, 42, 121, and so on. So it would just give you the exact page numbers. A database index works basically the same way, except that we would be indexing the string. Here we'd have an index, and then it would just have the address. Essentially, it would say, well, this is ID 1. I'm actually not sure how it works internally. It probably depends on the database. But the idea is that it's the same sort of association between email addresses and where they're located in the database. And ordinarily, it would be set up essentially as a hash or something equivalent so that this is a key value pair and we wouldn't have to search through all of the different possible email addresses. So you would just be able to look up the string and it would just have the corresponding ID. Again, I'm not sure of the details, but this is the basic idea. It's very similar in spirit to the way a book index works. Since we need to manipulate the model, we're going to make a migration for this. So let's close this down. This is the first time we will have made a migration directly. The way to do it is with Rails generate migration, and then the name of the migration, which in this case I'm just going to call add index to user's email. Generates the new migration, and then we can just go to db migrate. And here it is. So this is just an empty migration, essentially. It's got the class that, I mean, this doesn't matter. This is just inheriting from active record migration, but I don't even know what this does exactly. But I do know that I can edit this change method. What I'm going to do here is use the add index method. to the users table here, and then email attribute. So this would solve that efficiency problem I mentioned. This would prevent a full table scan. But the reason we're using an index in this context is because we want to prevent this uniqueness violation at the database level. And so the way to do that here is to say that the index has to be unique by giving it an option, unique, true. We save that and run the migration. Then that updates the database, and actually I should do bundle exec here, just for completeness. All right, we can look at the schema here to see what it did. All it did is it added this index right here. We can actually see the effect of this by running our test suite. Just hit return to run the whole test suite here. We could do bundle exec reg test. And you see here, wow, 14 errors. What happened? And the answer is that Rails actually has created, as part of the Rails generate model, a file that contains sample test data inside of what's called a fixture. So let's take a look at that. That's in test fixtures users.yaml. So if you look at it, there are actually a couple of things going on here. You can see that the email address is not valid, but that's okay because, in fact, the fixtures don't have to pass validations. More important in this context, though, is that the email addresses for these two records, 1 and 2, are the same. And so that's actually causing the problem, is that if you look here, it says active record not unique, SQLite 3, constraint exception. So this is actually nice. This is a feature, not a bug, in the sense that it's actually caught this problem with the database. So this is our red, right, in our red-green. The way to fix it for now is just to get rid of this. We're just going to make this whole thing empty. I'm going to put in just a comment indicating that it's empty. That's not an error. That's actually what we want. We'll be using fixtures later in this tutorial, but right now I just want to get rid of them. So what happens here is that the fixtures get loaded automatically by Rails. And as a result of the duplicate email address, it was causing the test suite to fail, but now we've gotten to green. And so the email uniqueness validation is complete. Or is it? There's actually one more thing. The issue is that some database adapters are case insensitive at the database level, so that this index we added, let's go to the migration. Some databases consider, say, user add this here is a user add example.com. Some databases consider that to be the same as this. So what we want to do is convert this first one to the second one. We'll just standardize on all lowercase. So what that means is before saving an email to the database, we want to change the case to lowercase. And the way to do that is with what's called a before save callback. So a callback is just a method that gets called at a certain point in the lifecycle of an object, in this case before save. So before we save a user, we want to make sure that the email address is lowercase. There are several ways to do this, but the easiest way at this point in the tutorial is to do this. We'll talk about this later on, but it turns out that when making an assignment like this, we have to do this self dot. Without the self dot, this would just create a local variable called email. That would not work. So self.email equals email.downcase. This is not completely idiomatically correct, and we'll talk more in this tutorial about how to fix this up. There's an exercise in chapter 6 of the Rails tutorial that improves it in one way, and then later on in the tutorial we'll actually do this in a slightly different way. But for now this is sufficient, and let's switch over to our guard tab and rerun the test suite, just to make sure we're still green. Great. By the way, if it makes you a little nervous making this kind of change without a test, that's good. It should make you nervous. And adding a test for this functionality is one of the exercises in chapter 6 of the book.